Okay, 10-4 is about surface area of pyramids and cones, and our objectives are to find the surface area of a pyramid and the surface area of a cone. So, key concepts, we're going to start with theorem 10.3, lateral and surface area of regular pyramid. So the lateral area of a regular pyramid is half the product of the perimeter of the base and the slant height, which they usually use like a cursive L to show slant height. So lateral area is 1/2 perimeter of the base times the slant height. Okay, then the surface area, which is all the total surfaces, not just the outside. The surface area of a regular pyramid is the sum of the lateral area and the area of the base. Okay, so surface area is lateral area plus the area of the base. Okay, then the lateral and surface area of the cone. The lateral area of a cone, of a right cone, is half the product of the circumference of the base and again the slant height, which is shown with a cursive L. Okay, so lateral area is 1/2 times 2 times pi times r, which is the circumference, or 1/2 times 2 cancels out, so we can just say pi r times the slant height. The surface area of a right cone is the sum of the lateral area and the area of the base. So again, the lateral area plus the area of the base. And we know that the area of the base of a cone is pi r squared. So we could also say surface area is pi r L times pi r squared. Or sorry, plus pi r squared. My bad. Okay, then we have some vocabulary. A regular pyramid is a pyramid whose base is a regular polygon and lateral faces are congruent isosceles triangles. Okay. Then the altitude of a pyramid or cone is the perpendicular segment from the vertex to the plane of the base. Okay, so if we drew a line from the top point straight down to the floor of the pyramid. Okay. The height of a pyramid or a cone is the length of the altitude. The slant height of a pyramid is the length of the altitude of the lateral face of the pyramid. So let's look at the difference. So like this segment here, where in the middle, where it goes from the vertex down to the bottom floor of the pyramid, is the altitude. The slant height is like if we would take one of these triangular faces of the pyramid and draw a point from the top of the triangle to the bottom of the triangle. This would be the slant height. Because that is going to be tilted, because when we draw the pyramid, this triangle is tilted. So the height, the altitude, and the slant height are not going to be the same thing. The lateral area of the pyramid is the sum of the areas of the congruent lateral faces. And last, the surface area of the pyramid is the lateral area plus the area of the base of the pyramid. Okay, so then if we look back at our drawing, this top point up here would be the vertex. This side here would be a lateral edge. We labeled the altitude already, and then down here, this would be a base edge. Okay. Couple more terms. All right, a right cone is a cone where the altitude is perpendicular from the vertex to the center of the base. Slant height of a cone is the distance from the vertex to a point on the edge of the base. So here where it goes from the vertex down to the bottom edge of the base, that would be slant height. Okay, this line where it goes from the vertex down to the center of the base here, that is the altitude. And that's the difference between the two. Okay, so then let's talk about the lateral area of a cone. The lateral area of a cone is 1/2 the circumference of the base times the height times the slant height. And then the surface area of a cone is the lateral area plus the area of the base. So this would be a base, and this drawing here is a right cone. Okay, all the vocabulary is done. Let's go ahead and start some examples. So number 1 says finding the surface area of a pyramid. Find the surface area of a square pyramid with base edges of 7.5 feet and a slant height of 12 feet. The perimeter P of the square is 4 times 7.5 because all those sides are the same since it's a square. 4 times 7.5 is 30 feet. Then it tells us the slant height L is 12. And we found that the perimeter is 30. So we have to do 1/2 times the perimeter times the slant height. Well, the perimeter is 30 and the slant height is 12. And 1/2 times 30 times 12 is 180. So now we need to find the area of the square base. Well, the area of a square base is side squared. Our side length is 7.5, and 7.5 squared is 56.25. So then we know surface area is lateral area plus the area of the base. Our lateral area is 180. The area of our base is 56.25. And if we add those together, we get 236.25. So the surface area of the square pyramid is 236.25 feet squared. Okay, let's go ahead and take a look at example 2, finding the lateral area of a cone. Leandra uses paper cones to cover plants in the early spring. The diameter of each cone is 1 foot. The height is 1.5 feet. How much paper is in the cone? Round your answer to the nearest tenth. So we need to use the lateral area formula, which is pi times r times the slant height, to find the lateral area of the cone. The cone's diameter is 1 foot, so the radius is about 0.5 feet. The altitude of the cone, radius of the base, and the slant height form a right triangle. So what this is saying is if we draw this cone, the altitude would come from here. The radius would go from the center out, so this is the right angle, and then we can use the slant height to make a right triangle. So they're just looking at something like that. Since it's a right triangle, we can use the Pythagorean theorem to find the slant height, because we know that the altitude is 1.5 feet and we know that the radius is 1/2 foot. So 0.5 squared plus 1.5 squared. 0.5 squared is 0.25. 1.5 squared is 2.25. And if we take the square root of that, we get 1.58. So that's the slant height. We need to know the lateral area. So we've got pi times the radius is 0.5 times the slant height of 1.5. Back up for a second. Pi times radius times slant height. Radius is 1/2 foot. Slant height we just found is 1.58. So all we did was substitute 0.5 for R and 1.58 for L. Okay, grab a calculator, type that in, pi times 0.5 times 1.5, we get 2.48. The lateral area of a cone is about 2.48 feet squared. Now, we didn't have to find the surface area because we didn't need to know the area of the base, because it's in a garden, it's dirt, right? We don't need paper to cover that part. Okay, this is where you pause the video and go ahead and try the check for understanding problems. And when you get done with those, you can come back, hit play, and check your answers. There are only these 2 questions to answer today. All right, so let's go ahead and get started. Find the surface area of a square pyramid whose base edge is 5 meters and slant height is 3 meters. So I'm just going to attempt to draw this. I'm not an artist, you know that at this point. Okay, so this is 5, and then the slant height is 3. Okay, so we need the surface area of a square pyramid. So we need to start with the lateral area. So let's go back. The lateral area of a regular pyramid is half the product of the perimeter and the slant height. Half perimeter times slant height. Well, perimeter, we know, is 4 times the side length, and our side lengths are 5. 4 times 5 would be 20. Okay. And then we need to know the slant height we have is 3. So we need to plug this in to figure out the lateral area. 1/2 times 20 times 3. 20 times 3 is 60, and 60 divided by 2 would be 30. Now we know surface area total is lateral area plus the area of the base. The area of this base is side squared. So 5 squared is 25. So surface area equals 30 plus 25. So this surface area would be 55 meters squared. Okay, then we need to find the lateral area of a cone with a radius of 15 and a height of 20. So this is going to be kind of like that second example we did earlier. Lateral area of a cone is pi times radius times slant height. Now, this does not give slant height. We have radius and height, but not slant height. So if I draw this cone, kind of, we have the height from the vertex to the center of the base. The radius is from the center of the base to the edge. We need to know the slant height over here. We know that the radius is 15 and the height is 20. So we can use the Pythagorean theorem like we did up here to solve that. So we need the square root of 15 squared plus 20 squared. So we've got 15 squared is 225. 20 squared is 400, so the square root of 625, which is 25. So the slant height is 25. Okay, so we've got that. Now, lateral area equals pi times radius is 15 times the slant height is 25. So 3.14 times 15 times 25 is about 1,177.5 inches squared, if you put it in your calculator. And we need to round to the nearest square inch, so we're going to round that up. 1,178 inches squared. And that is our answer. Okay, you should have everything you need to go ahead and get started on the homework. If you do have any questions, feel free to come up and ask. I'm happy to